Dear student, I am Dr. Harold Thomas, Professor in Applied Geology, Dr. Hari Singh Gaur Vishwavidyalaya Sagar. Today, in this course, I will deliver my lecture on Granulite Facies. I will cover this topic in two parts. In part 1, I will proceed under the following heads: introduction, mineralogical characteristics, subdivision into the zones and subfaces, pyroxene granulite subfaces, and summary. Hope it will be useful for you. On the basis of pressure and temperature, we can divide the metamorphic facies into three types, mainly: 1. Facies of low pressure, 2. Facies of intermediate pressure, and 3. Facies of higher pressure. Mayasiro originally recognized three different facies series. Number 1, a geolite, prehenite, pumpelite, blue schist, eclogite type. Number 2, a typical Barrovian type characterized by green schist, epidote amphibolite, granulite type characterized by paragenesis of kyanite selemonite type, and number 3, an Abukama type of green schist, amphibolite, granulite characterized by paragenesis of andalusite selemonite type. The facies of intermediate pressure or Barrovian type are listed on the screen in order of increasing temperature and pressure of metamorphism: A. Geolite facies, B. green schist facies, C. amphibolite facies, D. granulite facies. The granulite facies are described by Ascola in 1939, is based on the ideal assemblages in which micas and amphiboles are no more stable. The rock of this facies belong to the very high rank of metamorphites, in which muscovite is no longer stable, and consequently potash feldspar coexists with aluminosilicate polymorph selemonite. Moreover, in rocks of suitable bulk composition, orthorhombic pyroxene characteristically appear in place of anthophyllite, gaderite, or cummingtonite. The paragenesis of impure calcareous rock is similar to the amphibolite facies, the granulite facies rock in the deep-seated zones, and now represented in Archean's crystalline complex of the continental shield. For example, South India granulite terrain of the Indian shield. In anhydrous peltic composition, feldspar, selemonite, almandine, cordierite, and hypersthene are common assemblages. In basic assemblages, both orthopyroxene and clinopyroxene with plagioclase are found. Winkler 1976 called the granulite facies as a regional hypersthene zone because the diagnostic minerals hypersthene present in both peltic and basic paragenesis. The individual mineral in rocks of the granulite facies display a number of distinctive and persistent properties, like hypersthene is strongly pleochroic from green to deeper pink to yellow, and typically show a rather high Al2O3 content of 6 to 9 weight%. Garnet are rich in pyrope, almandine, and sometimes contain as much as 55% pyrope and up to 20% gracilorite. Microperthitic structure is characteristic of alkali feldspar, and the plagioclase similarly tends to the antiperthite. Quartz and muscovite is already consumed, that is, muscovite and plus minus quartz is absent. All amphiboles are absent, that is, anthophyllite, cummingtonite, hornblende, gaderite, and tremolite, and actinolite. Granulite facies are marked by a highly distinctive fabric. A number of metamorphic reactions have been suggested to count for the diagnostic appearance of orthopyroxene. Change of anthophyllite to hypersthene. Number 1, anthophyllite give rise to orthopyroxene plus quartz plus water. Disappearance of hornblende in basic rocks. Number 2, hornblende plus quartz give rise to orthopyroxene plus clinopyroxene plus plagioclase plus water. Number 3, hornblende plus biotite plus quartz give rise to orthopyroxene plus potash feldspar plus plagioclase plus water. Number 4, hornblende plus almandine plus quartz give rise to orthopyroxene plus plagioclase plus water. Marks the beginning of Granulite facies in peltic granulites. Number 5, biotite plus quartz give rise to orthopyroxene plus almandine plus potash feldspar plus water. Number 6, biotite plus sillimanite plus quartz give rise to almandine plus potash feldspar plus water. All the reaction involving hornblende, biotite, anthophyllite are divariant on account of varying Fe-Mg ratio and also condition of P water less than P total, as discussed later, that in the reaction start at certain temperature, but all equilibrium phases will be present over a temperature range until with rising grade all hornblende, biotite, anthophyllite disappear. The decomposition of biotite and or hornblende with quartz or plagioclase needs high temperature at normal pressure. Lowering of P water relative to P total would decrease the reaction temperature at constant total pressure. This allow breakdown of hornblende and or biotite at temperature nearly 700 to 800 degrees centigrade. Therefore, P water less than P total or P load is considered a specific condition for the Granulite facies rock. Turner in 1968 recognized amphibolite Granulite transition facies. Turner and Berrugan 1962 recognized two subfaces of the Granulite facies depending on the pressure or absence of hornblende and or biotite. Thus, two subfaces hornblende granulites and pyroxene granulites are recognized. Subfaces on the basis of divariant reaction because they occur over a wide range of pressure and temperature condition. Granulite facies divided into two subfaces, Turner and Berrugan 1962. Subfaces H2O, the hornblende granulite subfaces in which hornblende and biotite are present in the garnetiferous and pyroxene bearing assemblages of more water. Temperature when increased, the pyroxene granulite subfaces with less water or absent. First, hornblende granulite facies. Second, pyroxene granulite facies. Pyroxene granulite subfaces. Different mineral assemblages on the basis of ACF, AKF and A-F-M' diagram. Peltic and quartzo-feldspathictic assemblages. Number 1, sillimanite, perthite, quartz, plagioclase plus minus graphite. Number 2, hypersthene, perthite, garnet, plagioclase plus minus quartz. Number 3, hypersthene, perthite, quartz, plagioclase, that is also known as acid charnockite. If plagioclase is more than potash feldspar, then rock is called anderbite. Or potash feldspar more than plagioclase, charnockite, potash feldspar less than plagioclase, anderbite. Basic and mafic assemblages. Number 4, plagioclase, hypersthene, diopside plus minus quartz, that is also known as 2-pyroxene granulite. Number 5, hypersthene, garnet, plagioclase plus minus quartz, anderbite or basic charnockite. Number 6, diopside, plagioclase plus minus quartz, that is basic granulites. Calcareous assemblages. Number 7, diopside, plagioclase, gracilorite plus minus quartz. Number 8, gracilorite, diopside, calcite plus minus quartz. Number 9, calcite, diopside plus minus quartz. Ultramafic or ultra basic rocks, diopside, hypersthene. Number 10. In my previous lecture, we have discussed the introduction, characteristic minerals, metamorphic reactions subdivision into zones, subfaces and pyroxene granulite subfaces. Today, I will deliver my lecture on Granulite Facies Part 2. In this lecture, I will proceed under the following heads: hornblende granulite subfaces, pressure temperature condition of metamorphism during Granulite Facies, and summary. Hope it will be useful for you. Try to be regular in course. Turner in 1968 recognized amphibolite granulite transition facies, and Turner and Barughan 1962 recognized two subfaces of the granulite facies depending on the presence or absence of hornblende and or biotite. Thus, two subfaces, hornblende granulites and pyroxene granulites, are recognized. On the basis of divergent reaction because they have occurred over a wide range of pressure and temperature condition. Granulite facies divide into the two subfaces, Turner and Barughan 1962. Subfaces: more water, the hornblende granulite subfaces in which hornblende and biotite are present in the garnetiferous and pyroxene bearing assemblages of more water. Second, when temperature increase, the pyroxene granulite subfaces with less water or absent water. The hornblende granulite subfaces of Turner 1968 occurs in several regions. For example, the Broken Hill of New South Wales in Australia, the granulite terrain of South India. The age of granulites from South granulite terrain yield age at 2.6 and 3.4 GA. The in situ charnocitization characteristically dates at 2.5 to 2.6 GA and hence associated with Dharwar metamorphic cycle. This facies subfaces is gradational to the sillimanite potash feldspar zone of the amphibolite facies. The assemblage hornblende plagioclase diapside belong to the amphibolite facies, where hornblende plagioclase diapside hyperthin representing granulite facies. The rocks may contain biotite and hornblende. The typical basic assemblages are clinopyroxene, orthopyroxene, plagioclase plus minus garnet. Cordierite is constituents of some pellitic granulites, especially biotite bearing granulites. The reactions are biotite plus sillimanite plus quartz give rise to cordierite plus hyperthin plus potash feldspar plus water. Another reaction is biotite plus elbendine plus quartz give rise to cordierite plus hyperthin potash feldspar plus water. Biotite plus quartz give rise to cordierite plus elbendine plus hyperthin plus water. Different mineral assemblages observed in hornblende granulite facies on the basis of ACF, AKF and A-F-M diagram. Pellitic and quartzo-feldspathic assemblages. Sillimanite, garnet, plagioclase, quartz, potash feldspar plus minus graphite, that is also known as condylite. Number 8, quartz, potash feldspar, hyperthin, garnet, plagioclase, garnetiferous acid charnocite. Number 9, hyperthin, perthite, quartz, plagioclase plus minus biotite, acid charnocite. If plagioclase is more than potash feldspar, then rock is called enderbite. Potash feldspar more than plagioclase, charnocite. Potash feldspar less than plagioclase, enderbite. Basic and mafic assemblages. Number 10, plagioclase, hyperthin, diapside plus minus quartz plus minus hornblende, 2 pyroxene granulites. Number 11, hyperthin, garnet, plagioclase plus minus quartz, enderbite, basic charnocite. 12, diapside plagioclase plus minus quartz, that is basic granulites. Calcareous assemblages. Number 7, diapside plagioclase, gracilorite, quartz. Number 8, gracilorite, diapside, calcite plus minus quartz. Number 9, calcite, diapside plus minus quartz. Ultramafic or ultra basic rocks. Number 10, diapside, hyperthin plus minus hornblende. In some region, successive zones characterized respectively by amphibolite facies, the hornblende Granulite subfacies, hornblende orthopyroxene plagioclase subfacies, and pyroxene Granulite subfacies, orthopyroxene plagioclase subfacies constitute a progressive sequence of advancing metamorphic grade. Elsewhere, again there is a textural evidence in the form of corona and other replacement structures that pyroxene Granulite assemblages are in process of retrogressive metamorphism to hornblende Granulites or amphibolite facies assemblages. These field and textural relationships are constant, with widely preventing view that the Granulite facies represent high temperature of metamorphism. The temperature is of the order of 700 to 750 degrees centigrade to 850 degrees centigrade, as shown by the reaction biotite plus sillimanite plus quartz give rise to garnet plus cordierite plus quartz plus S2O 700 degrees centigrade 2 to 5 kilobar. Mg anthophyllite give rise to orthopyroxene plus quartz plus water 745 degrees centigrade 1 kilobar, carried out by Greenwood 1963. Muscovite plus quartz give rise to potash feldspar plus sillimanite plus water 662 degrees centigrade 3 kilobar by Day 1973. These reaction biotite plus sillimanite plus quartz give rise to cordierite plus minus garnet plus potash feldspar plus water has been studied experimentally by Holdway and Lee 1977, and the equilibrium condition of reaction are 700 to 750 degrees centigrade between 4 to 8 kilobar. The reaction is already complete in upper part of the amphibolite facies. Mg anthophyllite give rise to orthopyroxene plus quartz plus water. Xmg equal to 0.6 775 degrees centigrade 6 kilobar 680 degrees centigrade 5 kilobar. When Xmg equal to 0.8 775 degrees centigrade 6 kilobar 720 degrees centigrade 5 kilobar. The above two reactions MgFe anthophyllite investigated by Tever and Henrichsen in 1975. They also studied the above reaction in the natural anorthite and synthetic one and found the breakdown temperature as 835 degrees centigrade 6 kilobar and 750 degrees centigrade 5 kilobar. MgFe gedrite plus quartz give rise to cordierite plus hypersthene plus water 755 degrees centigrade 2 kilobar 705 degrees centigrade 1 kilobar. The reaction was carried out by Winkler 1966. Partial melting of amphibolite through the reaction hornblende plus quartz give rise to orthopyroxene plus clinopyroxene plus plagioclase. The reaction occur between 700 to 750 degrees centigrade at 4 to 10 kilobar beans in 1969. It seems likely that the Granulite facies pass a considerable range of pressure of kyanite almandine rich composition of hypersthene and the pyroprich garnet are believed to be reflect high pressure condition of their formation. The association of clinopyroxene plus almandine plus plagioclase also indicate a pressure of 8 to 10 kilobar at about 700 degrees centigrade. As already mentioned above, on the other hand, pressure of sillimanite plus cordierite in some Granulite suggests that these are formed at relatively lower pressure, may be as low as 7 kilobar. Furthermore, the pyroxene Granulite facies rocks are essentially dry or anhydrous, suggesting very effect on reaction, including the transformation of hydroxyl bearing minerals into anhydrous ores. Of example, Henrichsen in 1975 has shown experimentally that the breakdown of reaction of hornblende one natural and two synthetic occurs in temperature range from 850 degrees centigrade to 1020 degrees centigrade at 1 kilobar. P water, where P water equal to P total. These temperatures are not reached in regional metamorphism. On the other hand, lowering of P water relative to P total, that is P water less than P total, decrease the reaction temperature at constant P total, can be realized only in the deeper part of the crust where very little water had occurred in igneous rocks and to metamorphosed sedimentary which has lost most of their water either during an experimentally long period of regional metamorphism or during previous period of high grade metamorphism. In many areas, granulite facies of rocks are polymetamorphic and these facies of rocks are restricted to Precambrian. Dear student, today in this lecture we have discussed about the granulite facies 2. I have covered this topic under the following heads: hornblende granulite subfaces, pressure temperature condition of metamorphism during granulite facies, and summary. I believe this lecture was useful for you. For further studies, please read the textbooks, references and links given in the text. Thank you very much. For further studies, please read the textbook, references and links given in the text.